Today, we're diving into a real-life Dr. Jekyll and Mr. Hyde story. But this isn't happening in some old Gothic novel. It's happening right now, inside our own bodies. We're talking about one single bacterium with two very, very different faces. Let's get right into it. So, what if I told you that a totally normal bug that might be in your gut right now is also one of the most dangerous superbugs on the planet? This isn't some thought experiment. It's the real story of a bacterium called Klebsiella pneumoniae. For most of us, it's just a harmless passenger, but for others, it's a deadly invader. So, how can one tiny organism be both? Well, let's break it down. All right, first up, let's meet the Dr. Jekyll side of this bug. This is the version of Klebsiella that's a perfectly normal, everyday member of our internal world. You see, the first thing you have to understand is that this organism is actually supposed to be there. It's a natural part of that complex community living in our gut that we call the microbiome. And, alongside trillions of other microbes, it just hangs out, helps keep things balanced, and for the most part causes absolutely no trouble at all. And we're not talking about some rare bug here. It is incredibly common. This number, 38%, that's the peak rate it's been found in stool samples from perfectly healthy people. That means there is a really good chance that you or someone you know is carrying it around right now with zero issues. But what happens when its environment changes? Well, that change often happens in a hospital. And this is where the story takes a dark turn, and we meet Mr. Hyde. In this setting, our common gut bug can transform into a serious threat, becoming a major cause of what we call hospital-acquired infections. And check out this crazy contrast. Out in the community, you almost never find Klebsiella on your skin, but inside a hospital, a place just saturated with antibiotics, it's a whole different story. Up to 42% of patients can carry it right on their hands. And why is that? Well, all those antibiotics wipe out the competition, leaving the field wide open for tough, resilient bacteria like Klebsiella to just take over. And this is where things get really serious. Klebsiella is a classic opportunist. It doesn't usually go after healthy people. Instead, it preys on those whose defenses are already down. We're talking about patients battling diabetes or cancer, or people on therapies that suppress their immune system. Even the very tools meant to save lives, like catheters, can become a superhighway for this infection. And make no mistake, this is a huge problem. Klebsiella is a major player, causing up to 8% of all bacterial infections that people pick up in the hospital. That makes it a leading cause of everything from UTIs to deadly pneumonia and bloodstream infections. But believe it or not, the story has another, even more terrifying twist. So just when you think you've got a handle on this opportunistic hospital threat, the story throws us a massive curveball. A new character enters the scene. A hypervirulent, or super aggressive, version of Klebsiella that just doesn't play by the same rules. And this is an absolute game changer. These aggressive strains don't need a patient to be weak or have a compromised immune system. Nope, they can strike perfectly healthy people out in the community, causing these devastating, incredibly fast-moving infections. So how did scientists figure this out? Well, they noticed a really important clue. These hyper-aggressive strains often look really distinct, kind of mucoid or gooey under a microscope. And the geographic link they found was just stunning. In places like Taiwan, pretty much 100% of the strains that cause these community infections had this gooey look. Compare that to just 2% in other countries. This mucoid phenotype turned out to be a major red flag for a highly invasive bug. This extreme virulence leads to a truly horrifying illness, invasive liver abscess syndrome. A completely healthy person can suddenly develop this massive, pus-filled abscess in their liver, all caused by this super aggressive Klebsiella. But the infection doesn't stop there. No, from the liver, the bacteria can spread all through the bloodstream. It metastasizes, moving to other parts of the body. This isn't just an infection, it is a full-blown invasion. It can land in the eye and cause blindness. It can get to the brain and cause meningitis. It can even lead to necrotizing fasciitis, a flesh-eating infection. The stakes here are just incredibly high. So we've got two pretty scary versions of this bug, right? The hospital opportunist and the community invader. But what connects them? What makes them both so ridiculously hard to fight? The answer, unfortunately, is a problem we are all becoming way too familiar with: antibiotic resistance. Okay, so the bacterium's first line of defense is this group of enzymes called ESBLs. The best way to think about them is like molecular scissors. They just snip apart and destroy some of our most common antibiotics, like penicillin, making them totally useless before they can even do their job. But then it gets worse. When these bacteria figure out how to resist our last resort antibiotics, the carbapenems, that's when we are in really deep trouble. This is the bacterium's ultimate armor. It's like the final boss of antibiotic resistance, and it basically slams the door on our last best hope for treatment. And the consequences of that, they're just staggering. When someone gets a bloodstream infection with one of these carbapenem-resistant strains, their chance of dying can be as high as 50%. 50%. It's literally a coin flip for your life. This turns what should be a treatable infection into an absolute crisis. So all of this brings us to today and the enormous challenge that this single bacterium represents. Because what we're facing now is a convergence of these two really dangerous paths. Here is the nightmare scenario we're talking about. On one hand, you have the classic hospital superbug that's getting more and more resistant. On the other hand, you have those hypervirulent strains that attack healthy people. And they are now starting to pick up those exact same resistance genes. The wall that separated the resistant bug from the super aggressive bug is just crumbling down. And so I want to leave you with this one kind of chilling final question. In a world that's more connected than ever by global travel, what happens when these two faces finally merge into one? What happens when we face a single strain of Klebsiella that is both hypervirulent enough to attack healthy people and armored enough to resist our best antibiotics? That is the battle we are facing right now.